Okay, so here I'm recording a lecture on software testing and validation and verification. So let's start with software testing. Alan Somerville, one of the pioneers of software engineering, identifies two distinct goals for software testing. Number one, to demonstrate to the developer and the customer that the software meets its requirements. This goal leads to validation testing, where you expect the system to perform correctly as per what is required. For example, if the software is supposed to be used for entering information on heart patients, and the developer develops a software to enter information on memory disorders patients, it is not meeting the requirements because there could be certain features that are missing for heart patients, and there are certain features that are there for memory disorders patients, which is not really required for a clinic that takes care of heart patients. So, validation is about finding out if the system is meeting the requirements. The other part is to discover faults and defects in the software, where the behavior of the software is incorrect, undesirable, or does not conform to specification. For example, if the social security number has to be entered and it turns out that the format required for the social security number is that of a phone number, and doesn't match. So, or it could be that there's a text box to enter the name, and the text box only allows names with 8 characters or less. That's a problem. So those type of faults or defects are also identified during software testing. So one of the things that people do to test software is build test cases. Test cases are specifications to the inputs to the test and the expected output, plus a statement. So, for example, you are going to test the registration screen for a patient portal, or entering patient information. So the registration screen, does it have all the required forms and text boxes and radio buttons and check boxes and all that? Or maybe there's something missing. That could be, maybe you're testing the system to find out if all the elements of the registration form are in that registration screen. So what happens when you enter the registration data into the registration form? Where does it go next? If it shows you an error screen, that's not an expected output. After you enter information on the registration screen, it should take you to the next logical screen, and that is the expected output. Or it should say, patient information entered or registered, something like that. And here's the next thing. So that's the expected output. Test statement is what are you trying to test. Of course, you have the input and output, but what are you really trying to test? That is included in the test statement. Test data are the inputs that have to be devised to test the system. So there are different types of testing. One is the system testing. Now keep in mind that an EHR, or a clinical decision support system, or any large system is made of components. That means that it could be that there are individual systems integrated together to form a bigger system, which leads to the idea of system of systems approach. So many cases, EHRs are a system of systems, where you have a validation of your credit card information. That could be a software component developed by a company. Your registration screen, your databases, all those are developed by another company. That could be a main EHR company. Your barcode scanning could be a software component developed by another organization. So all these components are integrated together to form the larger system. So it could be that these components work well individually, but when they're integrated, does the system as a whole work well? That is a question that has to be asked, and we need to find an answer for that. So that is done during integration testing. Release testing is where the team ensures that the system meets the requirements. For example, if you have built a system, it looks very good. It doesn't have the provision to enter for heart patient, let's say, but there is no room to enter information on EKG or ECG, whatever. There's no room to enter cholesterol level for that particular patient. There's no room to enter, or there is no space on the form, on one of the critical forms, to enter some critical information on the patient. So what? I mean, you develop the software, it's working well, but it doesn't meet some of the requirements. So that's done during release testing. Where in release testing, a user who's supposed to use the system actually tries to see if the system works well as per the requirements. As I said, integration testing reveals errors on integration. Testing a new component, and when you add the new component and when you rerun that, the system as a whole, does the system really work well? That's also called regression testing, where you add newer things and see if this system is really working well. Here's the critical information: clear box testing and black box testing. Clear box testing involves identifying and testing the entire program code. You see where the program works. I mean, for those who have never done any computer programming, just to let you know, there are paths within a computer program where there are if statements, there are loops, there are branches, all those things. So clear box testing, you try to see if the program traverses all those things. If there is code that the functioning of the program would never use, then it's better to get rid of that program code. So clear box testing is very technical in nature and analyzes the program code, whereas black box testing involves testing if the system works for these particular inputs. For these particular inputs, we are expecting these outputs. Are we getting them? We don't care how the system is written inside. Or for another example, if you have electronic circuit board, you don't try to analyze the circuit. All you do is analyze the input and output. That's black box testing. In clear box testing, you analyze the circuit and you see whether the entire circuit is really used. That's clear box testing. It's also called white box testing. It's also called glass box testing. So there are different names for clear box testing, but black box testing is called black box testing. Very simple. So in release testing is a process for testing the release to the distributed customers. Usually in release testing, they take 4 or 5 or a bunch of potential users and see if it is really working. Many times, release testing involves black box testing because the customer doesn't know how the program is written, or doesn't care to know. He or she just wants to know if the program is working as per the inputs and is providing the outputs that are expected. Next comes performance testing. Performance testing is where you try to load the system with a lot of inputs and see if the system really works well. For example, if you have a multi-user system, 100 people using the system at the same time, is the system going to crash? Or is it going to slow down? what is going to happen. So that's what happens with performance testing. In component testing, you have particular components of the system that are tested. So one of the very important or critical parts of testing is developing the test case design. I don't want to dwell too much into this because you guys are health informatics students and not computer science students. Um, it involves, requirements-based testing, which is again finding out if the system meets the requirements. Partition testing is where we partition the system and see um, if each partition works well, and then you have structural testing, identifying the structure of the system, if the system is structured well. Requirements testing, you have, again, a systematic approach where you build test cases and see if those test cases are working or not. Then you have partition testings where we identify partitions for inputs and outputs. For example, there could be 100 different inputs, and you test. Let's test for inputs 1 through 10 if it is working. Then let's test it for 10 to 20 if it is working. So you partition the inputs and you see if the system works well for a particular type of input. So you are partitioning the system behavior in terms of the input that is that could go into the system. So in structural testing is, as I said, analyzing the the system, the structure of the system. I gave you the example of the electronic circuit, the program code. So it's basically clear box testing. Path testing is again a structural testing to see if the program path is used. Again, I don't want to dwell too much into this. Here is the important criteria that you guys need to know. Software cost estimation. Once the system has been developed, how do you ascertain the cost of the system? How much effort is required to complete each activity? These are some of the questions that you try to get an answer for to find out the cost of the system. How much calendar time is needed to complete each activity? What is the total cost of each activity? Now the cost could be measured using, how many people you're using to build the system, how many dollars per hour are you paying these people. If you're buying equipment, that has to be taken into consideration. So all those things are taken into consideration while you try to estimate the cost of the system. Factors affecting software pricing could be market opportunity. A development organization may go for a low cost. An established organization may go for a higher price because they already have their brand name. Cost estimate uncertainty could be, if you are not sure what to price, you price low and then try to go for higher profit. Contractual terms is where you have a contractual term established, and this is the cost, and this is how much time we are going to spend, and this is how many people we are going to have on the project. Everything is written in the contract, and you follow the contract. Requirements volatility could be an organization may say, okay, we are going to do this for $10,000. And the customer is very happy. He thought that he would have to spend like $100,000. He's getting something for $10,000. Turns out the developer says, well, for $10,000 you only get this. Now, if you want something else, you have to give us a little bit more. Then the customer will say, okay, okay, fine, I'll give you $30,000 more. Here, add these features as well. And then finally, the cost goes up to $100,000 regardless. So you buy in a customer thinking that the customer is going to spend only $10,000, but the customer ends up spending $100,000. So it's like when you go to a company that does kitchen and bathroom remodeling, they'll say, oh yeah, we'll get it done for $7,000. And when you go to sign the contract, it is maybe $9,000 or $10,000, who knows. So that's what this approach takes into consideration. Financial health of the organization. There's an organization that's not making a lot of money. You can't bargain for a higher price. Then you go for a cheap price and see what you can do with it. So there's estimation approaches. Top-down approach is one of them. You think about the cost of the overall system first, and then estimate the cost of individual subsystems. The bottom-up approach is the opposite. You think about the cost of the individual subsystems, and then you think about the cost of the overall system. There could be algorithms developed to estimate the cost. It could be an expert judgment where a person is an expert and says, okay, this should be the price. Or there could be estimation by analogy, that you spend so much for a project like this before, and this project is going to, is similar and therefore would cost the same. There's Parkinson's law, where the cost is determined by the available resources rather than the objective statement. For example, 12 months, 5 developers, that's 12 times 5, that's 60 person months. So how much do you price for each person month? That's Parkinson's law. The other one is pricing to win. Just tell a price where you can win. So once the software is developed, that's not the end of the story. There's going to be software maintenance. One example, if there is an EHR software that generates ICD-10 codes, CMS may come up with a new set of ICD-10 codes. Or maybe we are moving from ICD-10 to ICD-11. So what do? You have to change the software system to meet the requirements of ICD-11, right? So there's maintenance involved. There are different types of maintenance. There's these type of maintenance where the environment changes. You're moving from ICD-10 to ICD-11, so the environment is changing. So that's one kind of maintenance. Or there could be some bug in the system. There could be some defect in the system that was not identified before, and now you have to fix it. So there are, coding errors. There could be design errors, or there could be requirement errors. So maintenance to adapt to a different environment. This example of ICD-10 to ICD-11 fits to that criteria. Then you have maintenance to adapt, add, or modify the system's functionality. Maybe you never thought of a barcode identifier before. Now you would think your organization needs a barcode identifier. So what do? You add that functionality to the system. So that's another type of maintenance. Okay, this is very, very, very important. I want you to hear this very, very carefully. There are two things with regards to any system. It could be a software, it could be an Airbus, it could be a car. There are two things associated before you release that system to the customers. One is validation. Validation talks about, are we building the right product? And I have a video on this on Canvas where a guy wearing sunglasses keeps walking and talking about verification and validation. I thought the video was a little bit jittery, so I thought, the guy keeps walking. It would have been better if he was standing somewhere or maybe sitting somewhere. So validation is whether we are building the right product. For example, you have a big, nice airplane. You got best first-class seats. You got nice economy seats. there's a luxury suite inside the Airbus where you could have a bed and you could have like a television right next to you, and wonderful, um, all that beautiful. Guess what? There's one big problem with that plane. The problem is the plane never takes off and cannot fly. So you did not build the right product. Similarly, from a healthcare perspective, if you are required to develop a software for patients with depression, and then the development company ends up developing a software for patients with um, knee replacement problems, you're not building the right product. It could be the best system for knee replacement problems, but that's not what the customer wants. The customer wants a system for depression patients, right? So that's validation. Validation is finding out if a particular system meets the requirements or not. Verification is, are we building the right product? Let me go back to this airplane or Airbus example. There's a plane, looks nice, beautiful, got nice first class compartment, got a nice economic class, got a lot of bathrooms, spacious, everything beautiful. It flies, and it takes off and flies well. There's a small problem though. Once the plane has already crossed 2,000 miles in air, the tail of the plane starts jittering a little bit, which can lead to an air crash. Or the plane flies very well, but when it's about to land, it doesn't land very well because there's a problem with some of the parts that are involved in landing the plane. So you build the right product, but you did not build the product right. There was some problem. So let me go back to the healthcare example here. There's a nice EHR software meant for taking care of heart patients. Everything is good. Problem is that the customer uses a particular type of input that is not accommodated in that particular EHR software. And if, or maybe that input is accommodated, but it cannot compute that input properly because the program wasn't written properly for that particular input. So there's a bug in the software, or what we call a defect, and that defect has to be fixed. So these kind of things are identified in the verification process. So there is difference between validation and verification. Building the right product and building the product right. So please understand this difference. It's very important. And the guy on the YouTube video speaks about this and gives a few more examples. So I recommend that you watch that video very carefully as well. All right, so that's the end of this lecture. Thank you very much for listening.